Welcome everyone to S- Suchit Sharma YouTube channel. I don't know what to call it yet. Uh, Today we would be covering week 5 of D.B.M.S as a revision session. We would be covering 5.1 till 5.3 in this session. So as not to make this session too long, let's dive right into it. Okay, are the people in Gmeet ready? Okay, so let me bring this here. Let's go to week 1. A fine module outline or a quick module outline would be this particular 5.1 module would teach us what are the features of a good relationship diagram and atomic domains or atomic domains along with first normal form. Okay, let me I think I have it. If I can, no, it's better if I open this up. Let the pen open up. Okay, next I accept the agreement. Next, install. Let me just check how loud would I have to speak in order to have a good audio quality. I think this much volume is good.
Yes.
Let it download. Till then, let's start with what would be the good features of a good relation model. Okay, good relation design. Hmm. Try for free. Okay. Yes. Here it is. Right. Better. Okay. What would be a good relational design? It would be the one which reflects real world structure of a problem. Like while we are working in a company, let's say the weeks after week 4 till week 12 would mostly focus on the industry side of DBMS. While working in a huge enterprise, we there are specific roles called as database managers or database engineers who their whole purpose or their whole existence is dependent upon this having good relational design. What they do is they they make sure that data is clean, consistent, and easy to understand. Okay, they make sure that data is clean, consistent, and easy to understand. Now let's go further. What is a good schema? What is a good schema? Basically, a single line can tell us what's a good schema. That would be no repetitions. No repetitions. What do I mean by no repetitions? No repetition would simply mean that there would be no repetition of data in a relation, in a schema, or in a table, be it in row wise, be it in tabular form. But there basically should not be any repetition of data. Let me teach you with a practical example. I have Luckily I have this data set, right? Data set 3.7. Let's open it up. What do I mean when I am speaking of repeated data? Let's see. Let's assume this as a database table. Okay, Excel is not a DBMS table, but it really helps me tell you how the things works. Okay, so let's say you have, for this regional section, this regional attribute, you have the urban data repeated again and again and again, right? How would you identify while taking subset of this whole data set 3, let's call this trainee data set. Okay, how would you work on trainee data set? Let's say you chose the attributes region, you chose responses, you chose occupation, you chose education. Now once you chose these, rest of the data from this training data set won't matter. However, there's a very particular problem that may arise. How would you uniquely identify data? Let's say urban. The urban data is repeated again and again. This makes the data redundant and inconsistent. Same is the case with responses. This is not useful data while working in an enterprise. This makes your work harder and complicated. Hence hence is the need of database engineers. Redundancy and anomaly. Redundancy having basically means having multiple copies of a same. I think there is a problem here. Why is the pen so okay? Is it because of this? Okay, let's bear with me. I don't remember how to you know how to make the thickness thin. The redundancy basically means having multiple copies of the same data in a database. As I said, while considering this particular data, you had multiple copies of the same urban data set in the table. So let's go here. Let's see the original data. That was not the original data. This is the original data, where you have both urban and rural. Even better, if you go into states, you have Madhya Pradesh, Tamil Nadu, Uttar Pradesh, Karnataka. But there are multiple copies, as in this case. Kerala, the Kerala, instance is repeated. This makes our work complicated. It may lead to, as the PPT suggests, anomalies. It may lead to anomalies. What are anomalies? Anomalies are basically the inconsistencies that can rise due to changes in data in a database with insertion, deletion, and update. These problems occur in poorly planned or unnormalized data, as in what we do. We have completed Python, right? I think people, we have completed Python, right? Hello, just wait a second. Wait a second. Speak now. Speak now.
Hello, am I audible?
Yes, yes.
Okay, okay.
Suchit, Suchit,
Yes,
you
yes.
can't
Now,
hear.
yes, I think I can hear you now. Now say yes, yes, yes. No, it was my mistake. It was error on my end. Okay, yes, this one, right? Okay, better. No, 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 it was error on my side. Actually, I see this. Okay, so as we learned in in Python, what we do is we do silly mistakes. We have to rewrite the program multiple times before we get the program correct, right? We have to debug it. We have to optimize it. Even then, our codes can be made better by a good programmer or a good coder, or who has completed the degree, right? So these problems would occur in poorly planned. And who does poor planning? People like us who are noobs to this whole subject. Unnormalized databases where all the data is stored in one table, as in this is an unnormalized data. Okay, this is an unnormalized what do I what do we call it, relation. This is an unnormalized relation where all of the data is stored in a singular table, as you can see. There can be three kinds of anomalies, namely insertion, deletion, and update anomaly. So the names themselves explain it. The names themselves explain what they are. Insertion anomaly is the anomaly which occurs while the insertion of data occurs, while we are inserting some additional data or unrelated data to the record. uh, this is an example. We cannot add instructor in instructor with department if department does not have a building or budget. Let me explain this better. I think the table was here, right? So what are we doing? we cannot we cannot join instructor in instructor with department if department does not have building or budget. So we are joining this whole table with this table if department table does not have budget. Okay. So what they are saying is, let's say we are adding a data from here, right? Once we have made this table by natural joining. Okay, this particular table, that is instructor with department table, is made by performing natural join on instructor and department. Once the table has been formed, now we wish to enter data from instructor table, that is, let's say 101 Srinivasana, or let too complicated, 1 to 1 Woo finance with a salary of 90,000. If we want to add this data into the table instructor with department, okay, let me bring my pen. Okay, if we want to add data from here to here, it is not possible, and it would bring anomalies. Why would it bring anomalies? It would bring anomalies because it the instructor table does not contain data about building and budget. And you cannot you cannot add a let me show you. You cannot simply add data while not adding while not considering all the attributes. So while adding data, you must you know your data should be exhaustive upon all the attributes. As in, let's say I am entering data, so I must enter data for id, I must enter data for name, I must enter data for salary, I must enter data for department name, building, budget, all of these. It must not be the case that we are only entering data for ID, only for name, and let's say only for budget, and leaving these three people sad and not entering data in them. That cannot be the case, and this would end up showing us error. Now, where is okay? So, other anomaly that occurs is when we delete data. It occurs while on the deletion of data results in losing some unrelated information that was stored as a part of record that was deleted from a table. Okay, so let me explain you. Okay, they have given example, right? We delete the last instructor of a department from instructor with department. We lose building and budget information. Okay, so let's say this was the whole data that enterprise has. Okay, and they delete this the last human, that is this sing guy. What they do is they delete the sing guy. Okay, now this guy is Okay, so this data is hidden. Assume that the pink part represents deletion of data. Now once you have done that, what would happen is the data from this table, the data containing this table was deleted, right? The data that exists in this table is deleted. However, the data that exists over here, which has nothing to do with sync, okay, the data here in this table who had nothing to do with sync, because these are department, okay, a singular professor or a singular human does not represent the whole department. Some of the data would be lost from this table. What does this mean? That some useful information about department and budget, or where does the department hold, in which building is a particular department, that data is lost. That is bad. Why must this table suffer for the misdeeds of Mr. Singh? That is a case where anomaly occurs. Okay. Now, update anomaly, it is simple. When we change a data, which could have many records having to be changed, leading to the possibility of some changes being made incorrectly. Okay, so let's say when we change budget, when budget changes for a department having large number of instructors, the instructor with department application may miss some of them. Okay, so let's say this data also collects the budget, right? What this table tells us is ID number 12121, whose name is Wu and salary is 90,000. His department is finance, and he teaches in the building named Painter. Okay, and this building currently holds a budget of 1.2 lakhs. Okay, so let's say the data about budget. See, the budget of a the budget is okay. But let me bring it here. The budget is related to the building that is associated with. The budget is associated with a particular building. Now what happens is, let's say for the Painter building, for the building named Painter, we change the budget from 1.2 lakhs to 1 lakhs. So let's say where all do we have Painter? Okay, in fact, there are two buildings. There are two budget for the Painter building. One being 1.2 lakhs and the other being 50,000. Now let's see. The Painter having a 1.2. Okay. Let's focus on the Painter building with 1.2 lakh budget. Let's say this budget was changed to be 1 lakh, right? Now a data may have Painter, as in this case, as in this table, many times. It occurs here, it occurs here, it occurs here. So while updating the data of Painter, whose budget is 1.2 lakh, it may initially, or it may end up missing some of them. It may finally end up missing some of them, which is also not good. Okay, let's move on to redundancy and anomaly. So we have observed that redundancy results in anomaly. What causes redundancy? Actually, dependency causes redundancy. Let me explain what do we mean by dependency. So this table, let me see. Let me tell you. The building and budget attribute are dependent on department name. Okay, here and in the instructor table, name, department name, and salary are dependent upon ID. Okay, so any changes made in the primary key results in variation in the dependent clause. Any changes made in the basically the superset results in changes being made in subsets. How do we remove or at least minimize redundancy? We basically see, this is a really important word. We decompose, meaning partition the data. That's what they have done. Initially they made the instructor with department, by performing natural join. But what we do is, this table is actually of no use in the real practical world. So what they do is, they split the table they split the table into two useful tables having, appropriate or relevant primary keys. That's what they do. They basically decompose the data. So instructor with department can be decomposed into instructor and department, just as I told you. Good decomposition. This is an important line. This is an important line. What is a good decomposition? A good decomposition is the one where minimum dependency occurs. Okay, there is close to one or two dependencies that happens in a particular table. Is every decomposition good? No, because this would be, negation of this line. No, it is it needs to preserve information, honor the dependencies, be efficient, etc. Basically, normalization is a good decomposition. Normalization is a good decomposition. So till 1.3 we would be seeing these two words, these two, things again and again, one being decomposition and the other being normalization. What is this? Where is this? Decomposition. Before we start, let's see what is normalization. It would be better if we see what is normalization. Plus, let me check if the, is the session going on perfectly or not, or I was blabbering for about how many, for a good chunk, and then it did not get recorded. Okay, share amount. Okay, so it's going perfectly. Let's see what is normalization in D.B.M.S. Okay, let's check. Why is it happening this way? Let me see. Why Bing? I don't understand why this happens. I think there is some bug in my PC. Let me just change my browser. I want google.com to be that, but it is no issues, no issues. Okay, so let's see what is normalization in D.B.M.S. I think there are videos, good videos. Uh, you can watch these lectures. They are, really good. But due to copyright, I should not, watch them. I should not use them. What is normalization? Normalization in a database is a technique, design technique that reduces data redundancy and eliminates undesirable characteristics like insertion, update, and deletion anomalies. Normalization rules divides larger table into smaller tables and link them using relationship. The purpose of normalization in SQL or DBMS is to eliminate redundant data. Okay, let's go. Decomposition, write a rule. If there were a schema, then okay, then department name would be candidate key. Do you guys remember what is candidate key? What are the various keys that exist? No. What is the meaning of candidate key or the super key? These both keys would be used. Meaning? Okay, so primary key is all, sorry, my mistake. A candidate key is almost a super key. Candidate key is a super key. Okay, but it does not uniquely identify the data. Are? Okay, so every key is a super key if we define it. Then below it comes candidate key, and only one or two of them becomes, one or two attributes combined become primary key. Okay, so a primary key is always a candidate key, which in turn is always a super key. Okay, so let's continue. Denote as a functional of dependency. See, this is the problem that I faced again and again. Okay, they did not explain what functional dependency is, but they use the word here. Yes, yes. You have to, watch the whole week, use YouTube to learn it in deeper sense, connect the dots, and then you would understand. Oh, that's what they're teaching. Yes, yes, yes. If you are you? I don't think Arya, you are doing PDSA, right? Mm. Yes, yes, yeah. Yes. Even if you, as you can see, the GitHub Gate Smasher Jenny's lecture. Even I use this, and I have made a, playlist for PDSA. Whenever you would be learning, this specific playlist would help you a lot. Okay, so do watch these rather than the lectures. They Yes. So okay, let's continue. Okay, in the okay, let's start. This indicates in the instructor department, because the department name is not a candidate key. The building and the budget of a department may have to be repeated. This indicates to the need to decompose the what they must do is, now while telling these lines, they must also provide the, you know the tables here, so the student does not have to scroll again and again to the top. Yes, yes. Now, hmm, okay, so I think the discussion has stopped. Let's start again. Okay, the screen is visible. Let's start. So decomposition slide 2. Not all decompositions are good, as they said previously. Suppose we decompose employee data set or employee relation containing ID, name, street, city, or a salary. So basically, any enterprise would have this data about their employees. We divide the data, we decompose the data into two. One being employee, one that contains ID and name of the employee, and the other being name, street, city, salary, etc. That being stored in employee 2. Now there is a chance of name of the employee to be repeated. Very common name is, let's say, Yash is a really common name, Ajay is a really common name, Rahul. Many names are really common these days. So in a table there are chances that a name such as Raj, Yash would be repeated more than one times. So you cannot exhaustively or exclusively say or set it as a primary key to find or explain the whole tuple in the data set, which means that employee 2 is a weak entity set and cannot exist without an identifying relationship. Consequently, this decomposition cannot preserve the information. That is true. So the next slide shows how we lose information. We cannot reconstruct the original employee relation. Okay, that also is true that we from the two, let's say from these two, if we perform natural join, we won't be able to get employee. The employee data would not be, the employee relation would not be preserved. So this one, I think this is where I should use this. This one is a lossy decomposition. This one is a lossy decomposition. I figured out. Good. Let's see an example of lossy decomposition. Give me 1 second. Sorry. Mm. So basically, what lossy decomposition means is you decompose the data, and when you try to reconstruct the original table through natural join, it does not return the original data. Okay, which is shown in the example. You took employee, you split it into two, then you tried to reconstruct it using natural join, yet there was redundancy present in this table. As you can see, let's say they had Kim main, okay, so they had two different unique data that was present in the table employee. While you definitely split the data as the conditions that were provided in the previous slide. You split it into ID, name, and then okay, you split it into ID, name, and then split it into name, street, city, and salary. Okay. Now, while performing natural join, what would happen is this Kim would go with this Kim would go with this. Once that is done and that is copy pasted or added or appended, whatever the word you like. Once that happens, you then go to Kim 2. Okay, once that happens, you go to Kim 2. Again, the natural join produces two copies of Kim. So the table ends up being redundant, and you do not get the employee data set or the employee relation after all. This is a lossy decomposition which has to be avoided. Let me see. A lossless joint decomposition is a decomposition of relation R into relation R1 and R2 such that if we perform natural join of two smaller relation, it will return the original relation. Basically, what they're saying is, if we perform, we have to, divide employee in such a manner that while you perform natural join on the decomposed data, while you perform natural join on the decomposed data, you are again able to get, let's say you performed a natural join on the data, you are again able to get employee data set back. That's what basically lossless join decomposition means. Lossless being, meaning there is no loss. And here is an example. You performed decomposition on relation R, which was split into A, B, and B, C. While they perform natural join on both the projection relations, you were able to get the relation R back as it is. Okay. Now atomic domains and first normal form. Okay. This is where normalization starts. So in this, till we, 1.5.1 till 5.3, they have decided to randomly tell us normal forms. I have seen normal form 1, uh, this chord, what was its name, I think some BC some BCNF or something, is BCNF. And third normal form. And let me tell you Venn diagram of, let me show you the actual Venn diagram of, you know normal form Venn diagram, which would be, okay, normal form Venn diagram. Okay, I have to, normalization Venn diagram. See, it's something like this. Okay, first natural form, second natural form, third BCNF, fourth and fifth. What they have done is they just told us about first, third, and BCNF. A domain is atomic if its elements are considered to be indivisible. I think you know what this means. So this is not an atomic data because you can split the data into CS and 101. Right? Identification numbers like this can be broken up into parts, thus making it non-atomic domains. A relational schema R in the first, is in a first normal form. They have, you see, again they did not, make us understand what is the first normal form, but let's continue. Okay. Data is in first normal form when the domains of all the attributes of R, when all the attributes, meaning the, the heading, are atomic. The data present for a given column are atomic. The value for each attribute contains only single value from that domain. Can someone explain this line, this particular line? Yes, yes, yes.
Things. So that is what single valued means, I believe.
Okay. Can you repeat that?
Okay, so let's say in your ER diagram, right? We learned about this phone number being a multi-valued attribute, right? Do you remember?
Yes, yes.
Yeah, so you put phone number one, comma phone number two, and that is not appreciated because while searching for a record, let's say having phone number one, you won't be able to do it because your domain has multiple phone numbers. So the equality will not hold, right? Because phone number one might be there, but alongside phone number one, there will be something extra by writing a comma. So it's a multi-valued attribute, and multi-valued attribute. That's why it should not be. It is not atomic. So that's why they mention it single value in a highlighted fashion.
Yes.
Make sense?
Yes,
Or
yes.
if you want to add anything, you can. I might not be again completely true.
No, no, you are correct. You're correct.
Yeah.
Uh,
Okay.
let me tell the YouTube viewers, whenever you have problem like this, never shy down. Okay, never shy down, never skip. Always copy paste it in Google. Okay, first normal form is a property of relation in a relational database. A relation is in first normal form if and only if the domain of each attribute contains atomic values, and the values of each attribute contain only a single value from the domain. Okay, so let me explain this in a more simple manner. Let's say you have we have table now. We have table now. Let me show you. Let me show you. Okay, so let's consider the urban people. Let's consider the urban people because I am an urban people. Okay, no discrimination, but I am urban. That's why I'm choosing. Uh, let's say let's find a unique data that's that's basically unique to it. I forgot how to. Are do you remember how to bring just show a specific attribute in here? I forgot. Okay, so let's do. Do you find something unique here? Okay, time to travel 10 kilometers, right? Okay, so let's consider this data, right? What happened? Shift delete. Okay, and is there some way I can bring this here? Okay, now it's better to see, and let's remove shift all the data for a while. As you can see, the urban data, let's consider this. The urban has 32, urban has 34, urban has 43. Now what would now this much part would be considered in 1NF form. However, let's say you there was some stupid fellow who entered the data as like this. Okay, let's say someone entered it like this, 32/32 or 32/34. He tried to muggle up or compress the data into a single cell. Then this won't be in 1NF form. What he would be trying to do is, oh, why do I need two tuples? Let's complete it in one tuple. That's not allowed. That is not 1NF form. You one and this is 1NF form. Okay, now let's make the whole data bar the same how it was. Let's move on. Non-atomic value complicates storage and encourage redundant repetition of data. Okay, that's simple. Atomicity is a property of how elements of a domain are used. Okay, string would normally be considered indivisible. Suppose that okay, students have roll number which are strings in form of this. If the first two are extracted to find the department, the domain of the roll number is not atomic. Okay, that's what we learned. Doing so is bad idea. This leads to encoding of information in application program rather than in the database. Okay, this is not in 1NF form. Why is this not in 1NF form? The thing that I explained is they tried to muggle up. They were shy to use more tuples for the same data. So what they did was they entered two telephone number for puja in a singular tuple. If you have two telephone table and you wanted two telephone numbers and you want the data to be in 1NF form, you print another tuple with the same prior information, and each of the tuple should have one of the telephone numbers as shown. Let me show you here. See, this is in 1NF form. Puja Singh with customer ID is repeated, but the table number, sorry, the telephone number is not. Okay, they do not try to mug up the data into a singular cell. So, this makes the data not redundant and makes the data more readable and useful. Decomposition helps to attain a 1NF form for embedded one to many relationship. Okay, so shall we go and complete this? Okay, shit. It's better if I do this so that we do not see the answers and cheat. Right. Among among the following is not a feature of good database. Now I want answers from the audience. Uh, 23 Suraj.
Design must be promote redundant storage of data items. Second option.
The design is not a feature, right? Remember, it must not be a feature. So design must promote redundant. Okay, it should not. That's the correct answer. Let's go to the second one. Arya Arya Agrahari. Okay, let's move on to Shubdeep.
Yeah, I'm reading that question only. Just give me
Okay,
some time.
so
Which of
let me
the
read it for
statement?
you. Which among the following statement is are true about redundancy in databases? Okay, so let
So
tell me.
first one is true, right? When it will
Okay,
result in data anomaly.
redundancy may result in data anomaly. That is true. Now tell
May
me about
rise
this.
due to.
Redundancy may arise due to an unnormalized data. Is it true or not?
Yeah, I feel it's true because that's why we moved to normalization, right?
Yes. Redundancy mandates that a data item cannot have multiple copies in database.
Mandates that a data item cannot have multiple
They are
copies. Seems
playing
to be
with
true.
English here. They are basically playing with English here. Read these
But
lines.
that is that is the issue. For me, it seems to be true, right? When a multiple copies means redundancy, right, in some way or form.
No, 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 no. Let
No,
me
no,
explain.
it's false.
It is false. Let me explain this why it is
Yeah, yeah,
false.
yeah.
It
Please.
mandates, meaning that it approves that, meaning redundancy means that, let's remove the word mandates and input means. Redundancy means that a data cannot have multiple copy. No, no, no. Redundancy itself means that there are multiple copies, right? What this
Oh,
line
sorry, sorry.
is,
I missed the cannot. Okay, okay.
yes,
Yeah, yeah.
that's what I said. They are playing with
Hmm.
English.
And I was
Redundancy
stuck
can
with
be
multiple copies.
Yes,
Yeah.
redundancy can be reduced by appropriate decomposition of
Yes, it's
relation.
true. It's
It's
true.
true.
Yes. Which of the following is not a data anomaly?
Select anomaly.
Yes. In a database, okay,
A database changing a single data.
okay. In a database, changing a single data may require changing many records,
Update,
leading
I
to
think.
possibility of some data being made incorrectly. The situation is called,
Update.
yes, update anomaly.
Which of the following statement
Which of the following
is not
statement is are
true?
true for lossless joint decomposition? Uh, which is true for lossless join, right? It
Hmm.
decomposes into relation into smaller such that if we perform natural join, it will return the
It's
original.
true.
Let me complete
It's
this
true.
because it's my turn. Okay.
Okay, okay.
After all, I am learning, right? So it is
Okay.
true. This one is true. It decomposes a relation into smaller relations such that if we perform natural join of the smaller relation, it will return more tuples than the original. No, it's false. Uh, it decomposes a relation into smaller relations such that if we perform natural join, it will return lesser tuples. Even that is wrong. It is effective in removing redundancy from table while preserving the original data. Uh, I don't think that is what's the purpose of lossless join. However, this is true, but lossless join means that dividing the table data such that okay, yes, it is okay.
It's true,
It
right?
Yeah, it will
divides
be.
As
It's
the,
true.
yeah, final purpose is dividing, not joining. The
hmm,
dividing in such a way that you can go back to the
get back the
original table
original.
back
Yeah.
once again. Okay, so tell me about this one.
If a relation is in one NF, which of the
Okay, read it, read it,
so
read it.
okay, if a relation is in one NF, then which of the following is are true about the relation? The domain of all the attributes are atomic. Yeah, it's true. First one. A relation in one NF may contain one or more composite. No, false. It's false, right? In D.B.M.S, we assume that all relation. No, false. And the value of each attribute contains only a single. It's true.
So it is true that the value of each attribute contains only a single value from that attribute domain.
Yeah.
Okay. Uh, Suraj, it's your turn. Huh? The final question goes to you. Read the. Would you read it or do you want me to read it?
No, I am reading it.
No, no. If you are reading it, then read in such a manner that we can listen because this is recording.
You want to store information from books in database. Every book has a unique ISBN, a name and a publisher. Well, an author can also write to multiple books. We consider the following two relations, each of which are in one NF. Book, curly braces, ISBN, comma, name, publisher. Author, curly braces, ISBN, author. I think it fourth option will be right.
Okay. I have not read the question. Okay. I'm totally believing on you. If it's wrong, it's on you.
Okay.
Hey, don't worry. This is not a competition. Huh? What happened? What happened? I think it
Maybe you can.
is hard to load the table. Okay, let's check how much. Hey, it is a really good score, right? It is a really good score. But
So which one? Okay, this
so
one.
so in DBMS we assume that all relation are in one and a form by default.
Is
Okay,
it?
one and a form basically. Yes, yes, yes. Uh, all the
Yeah, it's
relation.
right.
Yes, because no, usually a dumbo would do only a dumb person would try to enter data like this.
Okay, okay,
Even we
okay.
know how to, like, if we are beginners, right? So even we
Hmm.
store the data in this manner.
Makes sense. But I really didn't assume it beforehand, so maybe that's.
Yes, 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 even
Uh,
I didn't. If if they have would have said, oh, your answer is correct, I would have just moved on without giving it a
uh,
second thought.
yeah.
In a video, let's say in a week two, I did very bad blunder. Okay, I explained a whole theory on why this would happen, and finally the answer came out wrong. That was so embarrassing, and it was live recorded.
It's okay. You are doing your best, man. It's okay.
No, no, no. But the plus point from that is I got to learn. I learned how that works. Okay, so let me once again check. Hey, am I not live? I should be live, right? Let me check. Okay, it would be in the live section, right? Yes, I am live. Let me take
Learned
a few
how
minutes.
that works.
Okay, so let me once again.
Is it?
One and a form basically. Yes, yes, yes. Uh, all the
Yeah, it's
relation
right.
which is shown in the example. You took employee, the instructor with department by performing natural join. But DBMS as in revision session, we would be covering good relational design. So it took us around 50 minutes to complete this. Let's increase our speed now, right?
Yeah.
Because
Just sorry to interrupt.
we have to cover
Yeah.
two more, right? Because that was the whole point in covering the covering the session in or splitting the session into two.
Yeah, but Sujit, just I wanted to interrupt a bit. So I just have a meeting lined up. Okay, I have to leave. So I
Yes,
will
yes.
take your leave. Okay. So I will. So how long will it take place? Money if it continues after 7, maybe I will be able to join back.
I don't think it would go that far.
Okay, okay. So I will look out for the recording. Okay.
Yes, yes, yes.
Yeah, yeah. Bye.
Bye. So that changes the dynamics. People, give me 1 second. Okay. Uh, so okay, we are back. Let's complete this. In this module, we would be understanding what are functional dependencies. This is quite a easy topic compared to the previous one and the coming one. So our goal is to devise a theory for a good relation. That's what our goal is. Okay. What we want to do is we want to decide whether a particular relation R is in good form or not. In the case that R is not in a good form, we decompose it into a set of relations R1, R2, R3 such that each relation is in good form. The decomposition is lossless joint decomposition. The decomposition is a lossless joint decomposition. The theory is based upon functional dependencies, multi-value dependencies, and other dependencies. Okay. Is there a way, where we can? Okay, there is. Okay, so I cannot do that. Okay, done. So let's move forward. Let's quickly go through this. Functional dependency for or FD is alpha, tending to beta, holds on R if and only if any legal relation. This is English talk. Let's not go into English talk, and let's understand what they're trying to teach us. Okay, simply a functional dependency is taking the two attributes. Okay, let's take these two attributes. Okay,
Yeah.
now let's call this alpha. Okay, let's call this alpha, and let's call this beta. Now what this would mean is, let's say we are using this sign. Okay, let's alpha tending to beta. Let's go to alpha tending to beta. Now what that would mean is that we can use alpha, that is elements in A, to uniquely identify elements in B. We can
B.
use elements in alpha, or the element alpha that is in A, to uniquely identify beta that is in attribute B. Can we do that? So let's say we are using one, and when we use one, we can uniquely identify it to identify beta being 4 in this case. Let's say we take 1 again, but here the value changes to 5. So this negates the theory that it must uniquely identify the data in B attribute. So the instance, so alpha, A tending to B does not hold, right? Because we
Yeah.
cannot reach to 4 uniquely through 1. Let's say we are a 1 is a guy, 1 is, let's say, Suraj, and 4 is me, and 5 is Subhadeep. Let's say we are using Suraj to reach, let's say we are using Suraj, and Suraj can either reach to me or to Shubdeep. We do not want that. We only want that Suraj should either go to him or me, but not both. So
Yeah.
this is a bad, this is a, what is, okay, control shift 5. So this is not a functional dependency. However, when we go from beta to alpha, now this is a good case because this is a functional dependency, because we are using 4 to uniquely identify 1. We can again use 5 to uniquely identify 1, and we are using 7 to uniquely identify 3. All in all, what functional dependency means is, if we are tending, let's say, x to y, let's say we are making a functional dependency from attribute x to attribute y, the attribute x must not contain any redundancies, that is repetitions. That's all it means. समझे?
Yeah.
Let's say if so y can have redundancies, y can have repetitions, but x cannot, because arrow points this way. Now let's say if this was the case, right? Let's say if this was the case, so y should not contain redundancies, but x can be redundant, right?
Yeah.
Okay, so I think you understood. Let's move forward. uh, as they say, BFDA is BFDA holds. Okay, now K is a super key for relational schema R if and only if K is redundant. K is a functional dependency of R, meaning R is functionally dependent on K.
Okay.
R is functionally dependent on K.
Yeah.
The thickness is something that irritates me. It is really hard to choose a thickness here. Okay, right. And K is a candidate key if it is a super key, plus alpha is a subset of K, and alpha is a also and alpha is also a functional dependency of R.
Yeah.
Now, now, a functional dependency allows us to express the constraints that cannot be expressed using super keys. Consider this schema. Let's consider this schema. Instructor department containing ID, name, salary, department name, budget, building. Okay, we can expect the following functional dependencies, meaning that building is dependent on department name, budget is also dependent on department name, and budget is also dependent on ID. But we cannot expect that salary to be dependent on department name, because you cannot say that, oh, CS people have 40,000 salary. No, let's say there are Ram and Sham in CS department. Ram may have 41 and Sham may have 39. This is not a functional dependency. This is not the case. However, you can say, okay, so building, let's say my mechanical building is coincidentally M. So M building is allotted to the department of mechanical students, or the budget of a particular building is related to a student through an ID. Let's move forward. We use functional dependencies to test relation to see if they are legal under blah blah blah. If a is legal blah blah. If a relation is legal under a set F of functional dependency, we say R satisfies this. Specify constraint on this set of legal relation. We say that F holds on R if all legal relations on R satisfy the. This is just a bunch of English. Okay, this is just, they could have simply said it in one line, but I don't know why. Okay. Suraj, just hold on a minute. I think there are, relatives or someone at the door. Okay, just wait a
Okay.
second. Okay, just wait a second. So it was nothing. Let's start again. Right, where were we? Functional dependency is trivial if it is okay. This is an important line. Function. Okay, did I do it or not? Okay, yes, it is. It works perfectly. Yes. Functional dependency is trivial if it is satisfied by all the instances of a relation. Meaning, ID can be a functional dependency of ID itself. Name can be a functional dependency of name itself. And ID and name can again be a functional dependency of ID itself. In general, alpha being a functional dependency of beta is trivial if beta is a subset of alpha, right?
Yeah.
So if we have this, you know, this being alpha, okay, let's say this list is alpha, right? Now we take out a particular few columns being this much, right? Let's say this much, this pink part. We take out the, we don't take out, we just copy paste this pink part into another list beta, into another list beta. Now this beta list is, now this beta list is a subset of alpha list, meaning it is a trivial case. Okay, it is a trivial case. Let's move on forward, just two slides. Functional dependencies are okay. So student ID is a functional dependency of semester. Okay. Student ID and lecture both can be a functional dependency of TA. So a TA can be assigned based on a lecture and to a particular student. So student ID and lecture are, functional dependencies of TA and semester.
Yeah.
Now, these are some functional dependencies. Closure of a set of uh, this is closure, right? Containing all the possible functional dependencies of a table. So F plus represents a closure. We call it closure of F. F plus is closure of F. It contains all the possible functional dependencies for a given table. So this much is complete. Let's go and quickly solve the problem. Right. Okay. So based on student, based on the table student in figure 1, answer the questions 1, 2, 3. Okay. Choose the functional dependencies applicable on the given table. Okay. Uh, Suraj, would you like to take this one, or do I should I do it?
I'm getting. Yeah, student ID, student name. Choose all
I think yes, ID
benefit.
can be a functional
Yeah,
dependency of student name.
and student ID and student date all joining date also.
Okay. Can hostel ID be a functional dependency of room?
No, 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 no.
Yes,
Uh,
that is true, because let's say the because something to be a functional dependency, this must this this attribute must not have redundancies. So let's say
yeah,
we are making table of hostel ID. So in the first two tuples itself, there we see there is redundancy, right?
yeah,
Okay, so let's skip. It's obviously not none of the above. If hostel ID is a functional dependency of SID, is valid functional dependency, then what are the possible values of S department at position indicated by ABC? Okay, ID, which hostel ID is a functional dependency of student department. Okay, if this is true, then what can come? Hostel ID is true. Then what are the possible values of A, B, and C?
I think CS must be there and ME must be there and ECS also must be there.
See, I think A would be CSE, as you said. B would be something random. A must be CSE. Why? Because we are just talking about this much data, right? We are just talking about wait a second. We are just talking about this much data, right? Let's leave out all the other data. So we have, so for something to be redundant, functional dependency, there must not be a redundant for there must not be something that is redundant. However, hostel ID has H3 twice, right? है ना?
Yeah,
So the only way to make it non-redundant is to enter CSE here, right? To enter CSE here. So the whole data is repeated and the table would eliminate it by itself. What do you say?
yeah, it will remember the same number of name of department.
Yes. And B and C can have anything they want, right?
Yeah,
Let's see. A must be CSE and B and C can be anything, right? B and C can be anything.
I think the data shows that mechanical and EC, then none other than else. And we will go through that also.
Yes, I think that's what you're saying. See, then see. Uh, if we see, Rishabh is repeated many times. See here, Rishabh is repeated many times. Here is Rishabh, here is Rishabh, here is Rishabh, right?
Yeah,
So it can be CSE here because a singular student with a unique ID. Two of the Rishabhs in the table have unique student IDs, right? And each Rishabh only can get a singular department. So if we put CSE here, we would have to put CSE in C1 also, right? So A and C are CSE, A and C are CSE, and we do not have idea about the B1. A and C are CSE, and B can also be CSE. Let's check, right? Let's let's take our chances with this one.
No,
We take,
in first case we can take CSE, 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 but in second case we can take CSE and ECS and ME in one
but
case.
C. A and C are the same student, right? A singular student can only take, Rishabh can only take one department. Now I cannot be student of mechanical and civil both at the same time, right?
Right.
So can only have Rishabh can only have a singular department, meaning A and C would always be same, right? So first and last would always be same. That is which is not the case in any other of any of the other options. Let's leave it. Let's go to third, and we would come back there later on. Third, choose the correct option among the choices given below. Is joining date a dependency of name and ID? Yes, I think that can be. Nah, no, that cannot be because
No, no, it may be start with a student name.
yes, because the data here is redundant.
Yeah, same because same data we cannot take first.
But the opposite or converse of that is true. ID and name can be a dependency of joining date, right?
Yeah,
Consider the following statement: functional dependencies always follow commutative properties. If A is a dependency of B, holds B. No, no, we just saw that. We just saw that here. If this is the case, this is not. This may not necessarily be the case, right?
yeah.
If A is dependency of B, then B cannot. B may or may not be dependency of A. The functional dependency always follow transitive properties. If A is dependency of B and B is dependency of C, then A is dependency of C. I think that is true.
Yeah, it's true.
So
Then
if there
second
is
option will be second
yes,
option.
second option, right? Choose the correct statement from among the following. A candidate key is always a proper subset of super key. We saw here, right? It is a subset of super key. All the attributes of a relation are functionally dependent on super key. Even that is true. A table may be such that there can be no super keys. I don't think that is the case.
No,
Functional dependencies are used for expressing logical constraints.
I think candidate key is always proper subset will not will right answer.
No,
I
no, no.
think.
It is true. Let me show you Venn diagram. Let me show you the Venn diagram. So once you see the Venn diagram, you would understand, right? See this one. Candidate key comes under super key, right? So candidate
Yeah,
key is a subset of super key. Now let's go to this. The functional dependencies are used for expressing logical constraints. Functional dependencies are satisfied in general. No functional dependencies. Uh, we use okay. So these are the uses used for expressing
logical constraint.
logical constraints. So I think this is what referring to, right? Specify
Yeah,
constraints on a set of legal relation. If we say F holds on R if all legal relations on R satisfy the set of functional dependencies F.
I think last option will be also there.
Yes. And B is not true because all attributes are not functionally dependent on super key, right? Because super key may have many data, right? Super key can be many things. SID can be super key, S name can be super key, this everything can be super key. So we cannot say that all the attributes are functionally dependent on super key, right? They're
Yeah,
functionally dependent on primary key. That would be but that would have been true, right? Sixth one, let F be a set of functional dependencies such that R satisfies F. Okay,
yeah.
let F be a set of functional dependencies such that R satisfies F. Now consider the following statement. An instance of R may be, wait a second, R satisfies R may be so that it satisfies some functional dependencies which are not in F. And you answer this one.
I think first one is true because an instance R may satisfy some functional dependency. That's
Which one?
not in I, not in F. As for example, is that A, that was then topic that then A is not in B.
Which one?
Before mm, upstairs.
I think
That's
A.
one. First example, A into B, oh, 1 and 4. Yeah, that's one, I think.
Okay, so let's start. Okay, let's leave this one if you want.
I think first one is true, so we can take with the first statement is true and second is false.
Okay. Choose the correct relation between the set of functional dependencies. Okay, so F and its closure. So closure contains all the possible functional dependencies. So this is true. F is a, F is a proper subset. Is a subset or is equal to the closure set, right?
Yeah,
Choose all the correct options from the following. All dependencies inside are logically implied by F, right? All dependencies may
yeah.
not
First
be
option
member
is
of F
there.
plus. No, that is not true. If a relation satisfies F, it must satisfy F plus. Okay, F plus can be infinite even for a finite relation. I think that is relative. What do you say? What do you say? Can it be infinite?
Yeah, it can be.
I think it can be if we are talking about, I don't think it
If
can be infinite. There always has to be a finite number of
no,
functional
that's
dependencies.
it follows that's example which if it not functional is R1 R2 in the theory section we had seen in the PDF. So this can be.
I think let's wait for this one. Let's. I don't think this is the correct option, so I am not marking this. If it is, we will mark it later on. Right? We
Okay.
have doubt in eighth one. Which among the following set is a trivial function of the this, right? So how do we tell something is trivial? We saw that how to make something trivial.
Alpha into beta. Alpha is refers to beta. That was the
No,
example.
this one, where did it go? That telephone one. No, it is one and F. What
No, no.
was?
Here,
I don't remember when.
just roll it
Let's
upwards. It was there. I just seen
on which slide?
in upstairs upward. I had seen.
See, it starts here, right? It starts here. So
That was the example I was telling about. R1 R2. No, no. This one is not.
So let's see the example once. We I think we would remember it, right?
Yeah. Trivial dependency, DBT.
Trivial functional dependency. Trivial functional dependency. Functional dependency. Okay, see, we left the fifth one,
Yeah,
right?
there
We
is.
did not read this. In general, alpha is trivial if beta is a subset. Okay, so alpha beta being dependent on alpha, where beta is a subset of alpha. Okay, so is this a subset of A? I don't
No,
think so.
I don't think so.
This one. See, D is a
Yeah,
subset
last
of
one.
this, and B is a subset of this, right? That the latter should be a subset of the former. I think every time I do this, I would have to, uh, you know, refresh the page.
Yeah, the page is stuck. Get.
Let's see, check our score. Even this is a good score. We lost 1.5 marks. Let's see where did we lose it. I hope we did not. Okay, so we made a wrong answer. So candidate key is not always a proper subset of super key. You were right there. All attributes of one relation are functionally dependent on super key. Okay. So what we learned is that super key subset is not candidate key. Okay. Candidate key is not a proper subset of super key. All the attributes of a relation are functionally dependent on super key. That one is true. Okay. Now, did we lose something? Did we lose? Okay, so let's go to the end and check the answer. We are yet to find
Yeah, that one, that one.
this
Yeah,
one, but we already marked the answers. Nah, only two correct answers. We lost half of the marks somewhere. Where did we lose? Okay, so
this one.
CSE, ECE, ME, and ME. Okay, so the former was the correct case. Since H3 must we are only talking about hostel ID and S department, and it has nothing to do with the rest of the data,
Yeah,
right? We are
that was I was telling you that it may take mechanical and ECS also in second case.
yes, because according to the question we are just focusing on this much data,
Yeah,
and we have nothing to do with the rest of it. So we have nothing to do with the rest of it. We just want to focus on this much, right? This is the data that we want, meaning A would always be CSE and B and C can be anything else.
yeah,
So we were correct initially. A has to be CSE and B and C can be anything else. Okay. So the only thing that matters here is that A is CSE. Only this stuff matters. Oh, sorry, I removed the wrong thing. Only this much matters, which is shown. The rest does not matter, right?
yeah,
If here we would have, if here A would have been CSE, it would have been correct. Okay, check answers. We are finally, 9 out of 9. Hey, okay, let me hold the video here.